Good afternoon, everybody. As published, I will be having a presentation on triggering of transistor by external power. In connection with that, I will be using today here the MOSFET. As usual, I have already shown you the role of MOSFET in previous program. I have a review now. For today's activity, I will be using this LED for glowing by the transistor. This is called 1 watt resistor, and they consume more current than normal LED as it is here. You can see, and I will be using 12-volt power supply for operating the circuit. So let's have a discussion about the components first. See this MOSFET having 3 legs, as you see: gate, drain, and source. Now drain is already connected by a red wire, and the red wire goes to the LED, and LED is connected to a resistor, and the resistor point one end is open. We will connect 12-volt positive there only, and source is connected to this green wire, and you note that green wire, wherever it ends, we have to provide negative supply there. So this is the briefing of the connection establishments. And for triggering the gate, I will use another component today, which is a power generator. That means this is a DC generator. It has got a handle here. I will open it, and the moment I will run it, it will generate DC current, which will be collected by these two wires. One is red and the other one is black. So first I will introduce you with our new component, which is called a DC generator, and I will operate first to show you that this LED, which is connected here, let me post my positive wire for the LED here itself, and the negative wire here itself. That means my LED will be verified fast whether it is getting its power from the generator or not. This is called hand cranked generator because the handle which is provided will be cranked by our hand. So the LED is off now, and I will show you. I have the handle with me now ready, and I take the handle back to show you that the LED will start glowing. See, this is glowing with a slight movement of the handle. See, and if I continue to glow, then I must rotate in a continuous fashion. So this is called the hand cranked generator. This produces almost 2 volt DC, which I confirm by glowing the LED across its terminals. And as for the concept of the generator, you know, if your speed of rotation will be more and more, the voltage production will be more and more, and there will be a time when my LED will be burning out. That means it will be blown, it will be destroyed by the voltage of the generator. So I rotate the handle here, you just confirm, and I rotate, and the LED is glowing. So this is a fundamental science. By the movement of a magnet, induced voltage and current will be absorbed across the terminals of a coil nearby, and the terminals from the coil are connected to the LED. So this branch we have already discussed in a video in my channel. There I had shown a motor was running with a fan. But today I have removed the motor from the system and showing that the LED is glowing instead to confirm that external power is ready. So now I remove it for your observation. Now let us connect power supply to MOSFET and see what happens. Now this is the positive wire of the MOSFET, and you can see I connect the positive wire of the power supply to this resistor where your resistor starts from this particular point. See how you count it. I have already told you on a particular section there are 5 holes, and all the 5 holes are connected to each other. And on that line, I have put my resistor wire at a particular point. And if I place this red wire also on another point there itself, then they will be connected internally. So that is not our topic today, but I just confirm you that how do you connect it on a breadboard. And now my duty is to connect again the negative. I connect negative as I told to this green wire, and the line where the green wire is dropping. See, I will be posting my green wire here. No problem. Let me post it. I have posted it. And you see, I will make the power on. By some reason, I told you already, the transistors are very sensitive to power system. So it triggered automatically. That means it got somehow some sort of response from the surrounding to glow the LED. And I show you again putting of the light, and this LED is glowing. I have dropped the voltage for this LED because of this resistor, otherwise it would glow double. So now I have measured this LED is receiving just 2.5 volt. Its actual voltage, operation voltage is 4.5, and that is why I told you this is just glowing half. But this is 1 watt LED, and their power LED, they are used in modern day lamps. So they generate a lot of light and heat also. So now my point is we have to make the LED off first, and I have already told you, and I repeat again, if you want to make it off, you have to connect a wire to the gate terminal, and gate terminal is here. See, one thing you might observe, when I touch the gate terminal, the LED glow has increased. That means it's somehow triggered, but it was not fully triggered. Anyway, if you want to make it off, as discussed earlier, you have to ground this open terminal. Then only you will observe the LED will go off. I do it before all of you. This is the ground terminal, and you touch it, so it goes off. Now our test will start, because you know already that power is established in the system, and we have grounded the gate, so LED goes out. And now how you trigger it again by using your external device, that is more important for all of us to follow it. So what I am doing, I'll put the generator positive, which is red, again on the gate terminal. I have to show it to you that I am connecting on the gate terminal. This is connected. See, I show you that this red is connected to the gate terminal, all five, and then the black wire I will connect to negative terminal, and our system is ready for verification. And what I am doing, you see the handle, I will rotate it, and you just see when I provide DC power of 2 volt to the gate with respect to source, see it started glowing. That means your MOSFET has been triggered. So what I am doing now, I will be showing you again. If you rotate, then your LED is glowing. See, after a certain time, LED again going out. This is important for all of us to observe. So, which is the path through which your gate is discharging its potential to ground? This is a question to all my viewers. because previously I have shown you, I have shown you, if you just touch by a naked wire like this is glowing, and let us observe for certain time whether that is getting discharging or not. So these observations are very important for all of us to take a look into the situation, because these are the education, the knowledge for all of us, how the MOSFET is behaving. See, it is glowing, it does not fade away. It fades away only when I connect this terminal to ground, as I have already shown you. I show you again, it goes out. So I remove this piece of wire, and you please, all of you, think for a moment, what is the knowledge with us? See, my generator red wire is already connected to the gate. But only thing is that this negative terminal is detached. The moment I touch it, this bare terminal of the negative started glowing. And when I put it in the negative part, we observe, although this was glowing, let us see whether it is continuing or going out. It has gone. Surprising. But for a long time, at least for a longer duration, it survived. So, what is my observation? I will tell you, and you just agree with me or not, I do not know. My observation says, I have already told you these two terminals, red and black of the generator, they are coming from a coil only. A single coil has got two terminals. That means this gate terminal is getting connected to the ground through the coil, and it is a continuous path. But why it gets delayed, the answer is important, and you have to please think over it. Why it is so delayed to discharge? This question is left to my viewers, or the persons or the viewers who will view it later on. Why is the LED which is glowing after triggering fades away slowly after a certain period of time and getting out zero? So this question is left. And you are all requested to answer this question on the comment section. And now, one of my viewer is already here, and I think I will request him to think over it. So please go ahead with your thinking, and we must discuss. Otherwise, you can put your comment here. Or otherwise, we'll discuss later on, no problem. But the reason is very important. Why does it slowly going out? Now we will connect this LED, which was there earlier for testing. Let me show you where do I connect. I will connect this LED across the gate and source, and I will tell you here is a big story. So, what is that story? Let me connect first from the source and then from the gate. So, 2 points I must connect. Observe carefully. This is source and this is gate, and we must see is already connected, and I must rotate, and you must see when I rotate this LED goes, but my LED did not glow. That means a wrong connection. I am confirming that it is a wrong connection. That means the point was not in a proper position. I hope this time I correct it. Now let us see when I connect my generator. You can see this LED, red LED is glowing, but the MOSFET is not getting triggered. This is again surprising. That means external power from the DC generator goes to the gate, otherwise this red LED would not glow. But it's a big fun. The red LED is glowing, but the MOSFET is not getting triggered. Again, another question comes into mind. This red LED is glowing. That means it confirms that the generator provides the 2-volt supply to the gate. So the answer is minimum resistance path is to be considered. So what is that minimum resistance path? Is very important in electrical science and electronics also. Now there was a path for the MOSFET and there is a path for the LED. There are two paths. So the current which is generated from the DC generator is flowing through the LED rather than triggering the MOSFET, because the MOSFET path is a high resistance path compared to the LED path. So now we will modify, and you please observe how I modify. This modification is again important. I'm having a register with me. I will show you my tray. My tray is having so many components for observation. Because while you work, you must provide some components with you. So I do have a register here. Another register here. Suppose I selected 10K register. I show you how I got to know that this is a 10K. If you observe carefully, this register has got the initial color brown. I focus it. And you just see the initial color is brown, the second color is black, and the third color is orange. That is focused now properly. Brown stands for digit 1, black stands for digit 0, so 1 and 0 is placed, and then orange digit in the third band signifies that number of zeros, that means three zeros after 10, that means 10,000 ohm. So this is 10k. Let me confirm using my multimeter. Whether our knowledge is correct or not, let us see. It is getting ready. There are two terminals I have to connect to multimeter, and I have to confirm in the meter that the register which I will use now, you see 9.90 something like that. That means it is 10k around. I measure it like this. Connecting by the meter probe. Brown, black, orange. So then I have to connect in another way that is more important for all of us to follow. I put it again, getting the system ready. Get is there. So what I'm doing, I'll be placing LED first and thereafter the resistance. I start my LED from the gate terminal and then I shift it to this point. See, the MOSFET triggers because of my touch. And then I'll put this 10k resistor one here on that particular line where the LED is inserted. And then I must connect it to the ground, that means the negative. It is connected. So as per your observation, I repeat, this LED starts from gate. Another terminal comes here which is not connected earlier. And from that terminal I start the resistor, observe it, and that resistor other end comes to the ground, that means the green terminal. And connection power is established. Let me show you now by rotating the handle. I am ready with my handle and I rotate my handle and you can see both is glowing. See, the red LED is also glowing and the white LED is also glowing. I show you. I see. It confirms two things. Your generator works. It provides power to both LED and then MOSFET. So now there is a time to discuss. In the previous case, when LED was single-handed, it was glowing but not the white LED. But now after inserting this 10K in line with red LED to ground, this red LED is glowing and your white LED is also glowing. That means MOSFET is triggered. You see? Now both become zero at the same time. They do not continue for a longer time. That means putting this 10K resistor in series with LED, I show you. Putting this resistor in series with LED, red LED to the ground from the gate provides one path to the current from the generator and another path through the MOSFET. So I have already told you The current prefers a low resistive path. Now, both the paths almost are same resistive because of addition of the 10K resistor. So LED started glowing, and then MOSFET got triggered, and the confirmation report was from this white LED was also glowing. So this is called, as published in my post, triggering of the transistor by external power. That means if you will be using a pencil cell, also you may trigger in place of this DC generator. So this is all about the concept of triggering. And now I find there are at least 5 to 6 viewers watching this, and I have a request to all of you. Please have some questions. If I do not answer even, I will invite in another live program one of my favorite person who will answer for us. Anyway, this was a very informative session to me also, because I enjoyed it a lot. Because I happen to know many concepts like triggering by external voltage, external power, and then concept of low resistive path and high resistive path, and then putting 10K in series with LED, the result is like this. So with this, I come to an end, and I will meet again maybe tomorrow after sufficient preparation. I will publish and will join. Thank you all for being with me in this program. Hope you have enjoyed. Any comment, please?